Now there is a JVM flag that will give us some information about strings in our application. And that flag is -XX:+ print string table statistics. It's all one word. I'm just displaying it on 2 lines here because I couldn't fit it on screen any other way. So let's see the output of this flag, and I think we'll create a simple application to try this out. So I'm going to create a new application, and we'll call this, I think, Exploring Strings. Now, unfortunately, there is a bug in the OpenJDK version 11, which means that you can't use this flag. You'll actually get an error. I will show you that error in a moment or two, but because of that, I'm going to configure this project to use Java 8. So the way I'm going to do that is to say I want to use a specific JRE, and it's the Java 8 JRE that I've got installed. If you're running Java 11, you might find that by the time you go to do this, this bug has been fixed. As at the date of recording, it is an outstanding bug. They have actually fixed it in the OpenJDK version 12 and above. So if you're running Java 12, 13, 14, you shouldn't have this problem. You should be able to run this flag and see the results correctly. But if you're running Java 11 and you have a problem, you might want to switch back to Java 8, as I am doing. But as I say, once I've written this code, I'll show you the error so you know what it is that we are talking about. So I'm creating a brand new project called Exploring Strings. And in here, I want to create a new runnable class. We'll just call it main. Because I'm in Java 8, I don't need to worry about packages. And the first thing I'm going to do then, I think, is actually just leave this as a completely empty method, and we'll run this application looking at the print string table statistics. So I've got a command window open here. I'm just going to navigate into the correct location for this project. So that will be Exploring Strings and then the bin folder. And there's my main.class. And I'm just going to check my Java version. And as you can see here, I'm running Java version 11. So I'll show you this error message. If I try and do, well, firstly, I'll just run the application and make sure there's no problems doing Java main, and that's fine. If I try and now add in this flag, so this is -XX:+ print string table statistics, and we'll press enter, and you can see we get this horrible, a fatal error has been detected by the Java runtime environment. This seems to always happen with version 11 of the OpenJDK when you run this flag. So unfortunately, you will need to be using a different version of the JDK at runtime for this to work. So I'm going to switch back to Java 8. I've made that switch off camera. If I just do again a Java version, I'm now running Java 8. So I should be able to do now Java and again the flag -XX:+ print string table statistics. And then the name of my class, which was main. And now we do get some meaningful output to the console. So let's have a look at this, and you'll notice that actually there's 2 sets of output here. There's a section called symbol table and a section called string table. So it's this bottom section that we are interested in. So what this is telling us is that the hash map, which is being used for the string pool in Java's memory, by default has 60,013 buckets. Now that's a much bigger number than the default for a hash map, which would have been 14. And it's telling us actually that there are already 731 different strings in the string pool. So how is that possible? Well, there's no way for us to find out actually what these strings are. I think I could be pretty certain that one of them will actually be the empty string, but the other 730, well, these have been populated into the string pool when the Java virtual machine started to run our application, even though our application isn't doing anything, because it will have been accessing different parts of the core Java libraries and all of their metadata, and those different parts of the core Java libraries will have strings in them, and some of those strings will have been placed into the string pool. So even before we start to create our own strings, the string pool has some entries in it. And what it's telling us is that the highest number of strings in a single bucket is 2. In the average bucket, it's less than 1. It's almost 0. So although there are 731 strings already in the string pool, because there are so many buckets, its operation is going to be very efficient. Now, because the actual bucket size is 60,013, if we were adding in the strings that we were talking about just before, the 2 strings mouse and chair, which I said would have been in the same bucket, actually won't end up in the same bucket. With a string pool that has a number of buckets of this size, actually mouse would be in bucket number 24,151 and chair would be in bucket number 42,941. We'll find out why that is the case, how we calculate the bucket number. Not that it's something that is of any use to actually know the bucket number, but it'll make sense how I know which buckets they'd be in when we learn more about hash maps. But this starting size of the hash map table for string pools, the 60,013, that has been the default number ever since Java 8. It may change in future versions of Java, but as at the time of recording, for Java 8 and all future versions of Java currently available, that is the default size of the number of buckets. So I'd like to write some code now that's going to generate some strings, and we'll see what happens to these figures. Now I'm going to write a really unrealistic example here. I want to generate a large number of strings that are all going to be stored in the string pool, simply so that I can then show you the main reason why we're talking about this, which is that there is a flag that we can use to optimize our application's performance when there are going to be a large number of strings in the string pool. This flag is only going to be of use in this circumstance, so we need to create an example which has a large number of strings. So let's do that. I'm going to use a loop, I think, to create these strings. So follow along with me if you wish to. Let's create a loop. We'll just loop with an integer. And I think we'll go for 10 million. I want to have 10 million strings. Let's go really extreme here. So we're going to loop from I = 1 to I is less than 10 million. Okay, that will actually be 9,999,000, but that will be good enough. We'll put in the incrementer. And then within this loop, what I'd like to do is to create a new string and add it to the string pool. So what I think we'll do is say, let's create a new string. And we'll do that by taking the value of I and converting it to a string. And then I'd like to put that into the string pool. So we'll call the .intern at the end. Obviously, normally, I.toString being something that's been calculated wouldn't be placed in the string pool. So it's a bit of a fake example, but now when this runs, we'll have created a lot of strings in the string pool. Actually, I'd like to make an extra step. There is a possibility that some of these strings could be removed from the string pool whilst this application is running to make space, and I don't want that to happen. So I'm going to also add these strings into an array list so that there is always going to be something referencing these strings. So let's create up here a new list of strings, which we'll call strings, and we'll instantiate it here. And then within the loop, I can add the string to the array list. And I'll just make sure everything that we need to be imported is imported. And that looks like that's okay. And then, because we're going to be making some changes to this, I'd like us to find out how long this code is going to take to run. So I'm going to do something which isn't very scientific. We're going to learn later in the course about better ways to time your code for the purposes of benchmarking, but this will certainly be good enough for now. So let's record the start time. And we'll record the end time as well. And then we'll print out to the console how long this took to run. So we'll say that the elapsed time was, and then we want to have in here the end time. I'll just import the date object first, I think. So it's going to be end.getTime minus the start getTime. And then that's going to be in milliseconds. So let's put at the end here plus ms dot for milliseconds. I think I'm just missing the plus here to concatenate my strings, and that hopefully is going to work. So let's run this. I'm going to run it again with the print string table statistics flag. I'll press enter. I think that's going to take a little time to run, so I'll pause the camera and I'll resume recording when it's finished. Okay, well that has finished now. It took quite a long time to run, as you can see, about 49 seconds. And again, that's not a very scientific measurement. We will talk about how to do this in a much more robust way later on. But if we say significant reduction in that in a few moments, then we know that we've managed to tune our JVM in an effective way. But before we get to that point, let's have a look at the string table statistics for our application now that this has run with that just under 10 million strings. The first thing to note is that the bucket size hasn't changed. There are still 60,013 buckets. But now, on average, each bucket will have 166 different strings in it, and there'll be one or more buckets with up to 196 strings in it. So it's a much more filled out string table. And this means it's much less efficient. Towards the end of our loop, when we're trying to add string number 9,999,998, for example, into the string pool, well, in order for that to be added, the virtual machine has got to check to see whether that string exists in up to 196 other possible strings in the relevant bucket. So at this point, because our string pool is so full, it's so condensed, it's going to be pretty inefficient. Now again, this is an extreme example, but being aware of the density of your string pool, particularly for very big applications, is definitely something to be aware of and to monitor, because if it is getting to be quite dense, that could be something which is going to be slowing down your application.